Hello and welcome to Steel Talks, a podcast by ArcelorMittal hosted by applied futurist Tom Cheesewright. Tom is going to be talking to members of our global leadership team about the topics that will shape our future. In today's episode, Tom chats to Olivier Vassart, CEO of our Steligence business, about how steel can support the decarbonization of the construction sector globally and the holistic benefits of our suite of Steligence solutions offer.
Hello, Olivier, and welcome to Steel Talks. Please, could you introduce yourself?
So, thank you to have invited me. So, my name is Olivier Vassart. So, I'm working at ArcelorMittal, where I am Chief Executive Officer of Steligence.
Fantastic. Can you describe for us the carbon challenge in construction and infrastructure?
So, today, construction and infrastructure worldwide are representing about 40% of the global carbon emission. So it is really a big part of the emission of the planet. And we know all that we face a big challenge to reduce these worldwide carbon emission. It means that as company which is providing material into the construction market, we have a big responsibility to change the future.
Because that percentage is enormous, but also the sort of the total amount of emissions looks set to grow as well with expansion of our infrastructure and housing and everything else.
Yeah, it is clear when we look at the previsions, we have the worldwide population that will grow, but we will also have the worldwide population that will grow their way of life. It means that when we combine these two tendencies, we see that between now and 2050, 2060, we will need to double the amount of construction compared to what we have now. It means that each meter square which is existing today, we need to double it. It means even if we renovate properly all the building and infrastructure we have, we will still need to build the same amount that what is existing today. So the challenge is enormous.
To what extent are we seeing the industry address that challenge? And are governments creating incentives for them to do so?
So we see several drivers. So we see first the industrial drivers, which are the reduction of the carbon emission of the industry itself. So in the steel industry, but also in many other industries, people are now taking it seriously. We are at ArcelorMittal taking clear target to reduce our direct emission. But this can only work if it is combined with target given at the end user stage. And we see it also popping up. We see regulations appearing in different European countries to limit the carbon content of construction. So when I say limiting the carbon content, it means that the builder will have a CO2 budget to build a building. So a CO2 per meter square built threshold that he cannot exceed when he wants to do a building. And of course, these thresholds will decrease between now and 2050 to ensure that the different countries and regions will globally also reach their target. So if we want to succeed, we need to take the market in sandwich. I want to say on one side to work on the producer of goods, and on the other side to play on the user of the goods and push them to meet somewhere. We must not believe that industry alone can do the entire journey. It's not possible. It means that the user, and here we speak about construction. It means the building owner and the builders will also need to change the paradigm and to work on their side of the coin.
We've we've seen some experiments with those sort of ratcheting carbon budgets. Do you see those expanding out to other countries?
So today there are two countries which have already put legislation in terms of carbon budget. It is France, where what they call RE 2020. It's a new regulation which gives CO2 threshold for a different type of building and for a different period of construction. We see Denmark, which has also put a carbon budget per meter square built. Then you have Netherlands. They have taken another path, but which is as valuable as the carbon budget, is what we call CO2 monetization. It means for public sector, when you need to build a bridge or one infrastructure, of course, by law, you need to be the cheapest. That's the way the things are done. But on the top of the cost of the construction, they add a cost for the embedded CO2 of this construction. So lower you are in CO2, lower this extra is going on the budget. And finally, they choose the cheapest, but with the cheapest when they combine both. So depending the virtual cost you put to CO2, you can significantly influence the direction where you want to go. So we see that in the Netherlands, steel has taken a larger market share thanks to its benefit in terms of CO2 in this system.
Wow. And are you seeing more generally these shifts in regulations drive new conversations with you about changes in materials?
Yeah, it is clear. I would say in a building, you have different way to decrease CO2. And one way, as I said previously, one way is to decrease the carbon content of the material. That's obvious. It's the first thing to do. You do the same building, and then you change material into same material, but with less CO2, you will decrease the CO2. But that's not the only leverage. We see that now people try to use material in a more intelligent way, in a more efficient way. And I think that needs also to become the first driver for the builders and the engineering office, is how to minimize the use of material. So it's a bit schizophrenic from a steel producer point of view to explain to people that they need to use less steel, but it's fundamentally the case. It means we need to design building with more efficient steel, more higher strength steel to decrease the quantity of steel. We need to do building where we will more intelligently combine material, because it would be naive to believe that one material is the solution. The solution is clearly in the intelligent combination of material. And that's what my people in Steligence are doing daily. It's to help investors, real estate developer, architect, engineering office to intelligently design buildings, optimizing also the sourcing of material to also work on the decarbonized material stream. And it's only when you combine these both ways of designing that you see a clear difference in terms of carbon content in the building.
It's really interesting. As you say, there's lots of different approaches to addressing the carbon challenge. And one that I'm really interested in is actually changing the nature of the buildings themselves, the design of the buildings to extend their usable life. Can you expand on that somewhat?
Yeah, one of the lever, and again, a bit crazy from people who sell material, but It is not building. It means that we need to try to build building to have them living longer. And today we see a bit everywhere in each of the market that we destroy building to make new ones. And most of the time, the building we destroy, they have no integrity problem. It means they could stay there for the next 20, 30, 40 years. The problem is that they don't correspond anymore to the need of the user or to the need of the market. It means that today, when we design building, we need to think them a bit differently. We need to make them more flexible. So one simple thing to understand when I speak about flexibility, it's to avoid as much as we can pillars, avoid as much as we can walls, even to forbid the concept of wall. Because a wall, you cannot remove it. A pillar, you cannot remove it. It means that when you have construction with really large open plan, when you change the tenant, when you want to use differently the building, you can remap totally the interior of the building. You want an open space, you do an open space. You want individual office, you do individual office. You want meeting rooms, you do meeting rooms. But if you build your building with walls, individual office, and a wall between each individual office, then you are stuck. You cannot change anymore. So this is something we need to rethink. We need also to separate the function. In many buildings, we have the concept of bearing facade. It means we have again a wall at the facade, which is at the same time the bearing wall, what take the load to put them on the ground, and which is also the separating element between the inside and the outside. But when the regulations are changing for thermal isolation, for all these type of things, you cannot change this wall. It means, again, you need to destroy the building before putting a new one. When you separate the function, okay, you can unplug the facade and put a new one. You can transform an office into an hotel by changing the facade, because an hotel with glazing facade will obviously not work. But if you can change this, then you save a big part of material. And clearly, thanks to composite construction, so steel combined intelligently with concrete, you can build really large open floor plan that will bring you this flexibility in use and this flexibility for the future.
I guess that's particularly important when you connect it to what you said about the expansion of urban space, because naturally as cities expand, what you want in different bits of the city change. So, you know, a lot of the buildings we're building in the next few years, we might want them to still be there, but to be something completely different in a very short space of time.
There is a clear example of this. In 25 years ago, so I'm living in Luxembourg. And 25 years ago, the city of Luxembourg has put in place a concept of park and ride. It means at the entrance of the city, they have built huge multi-story car park. And from this car park, with public transportation, you could go into the city. But after 25 years, these car park, they are there. They are perfect. They continue to work. But they are already deep in the city because the city expanded, like all the big cities in the world. So for the next generation of car park, because now they will rebuild car park at another layer, more far from the city center, what we think about, it's not to build a car park, but to build an office building without facade and temporarily put cars in it. It means that within 20 years or perhaps 30, I don't know, but one day, probably these car parks will be again in the middle of the city. It means that at this period of time, you just need to plug a facade to put ventilation and all these things. And then you have an office building. And you build again a car park 10 kilometers or 15 kilometers away. You know, this way of thinking, it's this way of thinking that needs that we need to ensure that we can change the paradigm.
If we do need to take a building down or fundamentally change it at the end of its life, are there choices we can make in its design now to reduce the lost energy at that point?
Yes, that's also a really important game changer. Today, the building are taught to survive, let's say. Designers are doing them to withstand their lifetime. But we are not yet taking the end of life as a driver when we do the design. So this can be explained by many driver, let's say. You design it today and you already need to think about what will happen in 20, 30 years. You are an investor, you know that, you will sell the building when it will be done. So I would say within 30 years, you will not be in charge anymore. So there are many drivers which are there. But clearly, when we demolish a building, of course, today people are doing their best to recover material. And I would say, fortunately for us in the steel industry, the recovery of steel is really easy. It means we can really easily recover all the steel which is in a building and recycle it to the new steel. That's also a particularity of our material, is that we take back the steel and we redo steel. So it's really a closed infinite loop. But again, to look beyond, to look at the future, we need to find a way to dismantle building and not destroy building. Because when you dismantle these buildings, then you recover the material, but you don't need to recycle it or to reprocess it. You can reuse it. And there steel has, again, a tremendous advantage because steel is assembled in buildings. It means column, beams, floor, elements, they are bolted together. It's a kind of giant Lego. It means what you can bolt it, you can debolt it. The thing is that you need to take extra care when you design. You need to change a bit the design. Fundamentally, the building will be a bit more heavy. So the building will be a bit more expensive by default. It means that the investor, the builder, which think about that today, need also to be rewarded today for this. Because if only the one within 20 or 30 years will be rewarded when we dismantle, this will not appear large scale. We see people really committed. We work with customers really committed and going into this direction, but they do it because they are committed to change the world. But if we want within 15, 20, 30 years have access to a massive database, a massive amount of material which can be reused, it needs to be prepared today.
The choice of steel itself is also part of the solution. Can you talk about the impact this can have on the carbon footprint of a building?
There are two ways to answer this question. So the first way is that clearly the choice of the right steel is really important to drive the carbon footprint. So we have different type of steel available for construction. And depending on the building, depending on the use of the steel in the building, choosing the right steel can decrease the amount of steel which is used in the building. It means that proportionally, it will decrease the carbon intensity of the steel part of the building. So that's one of the driver is to use the right steel. And the right steel is not always the same steel. I cannot tell you, okay, you take only ultra high strength steel, you put that everywhere in the building and it's the solution. No, depending on the use, depending on the design, depending on the building itself, we need to find the right one. And that's, again, what our engineers are doing with architects, designers, and real estate company is to help them to choose the right one. Second lever is how can we combine steel with other material to have the perfect use of the material in the building. So to have the concrete, because you need to have concrete in a building, you need to have concrete parts, and how to connect the steel and the concrete properly to leverage on both material, and finally have less concrete and less steel in the building. And of course, choosing steel with lower embedded carbon, like the X-Carb steel that ArcelorMittal is putting on the market, is also clearly an advantage, because with the same amount of material, the same bearing capacity, you can again decrease significantly the footprint. So when I look at what is commercial today, so I don't speak about what will be there in 2030 and 2050. With what is commercial today and what ArcelorMittal can offer today, you can easily divide by 2 the carbon footprint of a building compared to the actual benchmark and the actual way people are building. So remember, from the beginning of our conversation, building and infrastructure represent 40% of the carbon footprint of the planet. So if we can, in all the building and infrastructure we do, thanks to intelligent design, thanks to the use of X-Carb steel, thanks to the combination between the material, divide by 2 this, the scale is gigantic. The gain that we will have is gigantic.
There's a challenge, I guess, to this, which will come from a lot of investors or constructors, which is around cost. Is there a significant sort of cost penalty for shifting to these higher strength steels or the low carbon steels?
So when you do this intelligent design, combining the material together and using higher strength material, it means higher strength steel and higher strength concrete, we can say, okay, the material is more expensive. It's clear. But you will use less material. So already at this stage, you will save money. It's not that it will cost you more money. Per meter square built, you will save money. It will be cheaper. Of course, when you go to purchase the material, 1 kilo of steel or 1 kilo of concrete will be more expensive per kilo. But per meter square built, it will be smaller. So finally, you will save money. And when you look at the extra for decarbonized steel, I made some calculation on this. And when you take a building, an office building, to use X-Carb steel, barely everywhere you can use steel in the building. For the investor, it will cost him between 1 and 2 euro per meter square built. 1 and 2 euro per meter square built. It's even not the thickness of the line. It's a no-brainer.
It's a tiny amount.
Of course, the steel itself, X-Carb, we have a premium. But this premium is then entering in the full budget of the building. I think you can easily compensate this premium by the gain you will have using higher strength material in composite construction. So for me, it's a no-brainer. And often when I have the chance, and I often discuss with big real estate company, they tell me that for them, it's a no-brainer. The thing is that we need to make them aware about this. We need to be involved at early stage in the project. Because in a construction project, the cost of a change is exponential with the closest you come to the physical construction. So if people come to us when the building start to be built, when the day they purchase material, it's often late because the cost of this change is not affordable. If they come to us when they start to design the building, then the cost is zero. We just need to guide them, and we do that together with them on what is the best solution that ArcelorMittal can offer them.
Fantastic. Thank you so much for your time, Olivier. Really interesting.
Thank you very much, and I hope your listener will enjoy the podcast.